Hello everyone. Welcome to the Gate Engineering online learning classes. In this video, we will represent any signal using a step function. The signal we have given that is band limited and its width is 0 to 1. We want to represent this signal in terms of the step function. I mean in terms of the UT. So how we can represent this signal? Just we know this is our UT signal, unit step signal is defined for t greater than 0 and its value is 1 for t greater than 0 and value is 0 for t less than 0. Similarly, if we plot the shifted signal of this ut, we will get u of t minus 1 and signal will start at t equal to 1. Now, to get the desired signal, if we subtract u of t minus 1 from ut, this part will cancel out. So we'll get a minus b and we'll get the signal which is our desired. Its width is 1 between 0 and 1. So we can represent this signal by u of t minus u of t minus 1. Now there is one trick to remember how we can solve this. A step amplitude is determined by subtracting amplitude just before transition from the amplitude just after transition. It means we will have to see where is our transition. One transition at t equal to 0. Just before transition its amplitude value is 0. Just after transition its amplitude value is 1. Similarly, we will have to check another transition that is at t equal to 1. Its amplitude value is 1 just before transition and amplitude value is 0 just after transition. So in this given signal, we have a two transition, one at t equal to 0, second one is at t equal to 1. So we will have to write two function for each transitions. Okay, so first we will see for t equal to 0, we can write u of t, and for t equal to 1, we can write u of t minus 1 because that is a shifted one. Now we will have to check what is the amplitude of the signal. Amplitude can be defined by subtracting amplitude just before transition, that is 0, from the amplitude just after transition, that is 1. So we'll have to subtract 0 from 1 for t equal to 0. So we will get 1 minus 0 in the amplitude. Similarly, we will have to check the amplitude for t is equal to 1 because we have another transition at t equal to 1. So amplitude just before transition is 1 and amplitude just after transition is 0. So we will subtract 1 from 0. So here we are getting u of t. Here we are getting u of t. And here we are getting minus of u of t. We will add both of the signal to get our desired function for the given signal. So function can be represented by u of t minus u of t minus 1. Now come to the problem, how we can represent this given signal in terms of the step function. Here first we will identify the transition at t equal to 2, second transition at t equal to 4 and third transition at t equal to 6. So now previous amplitude just before transition at t equal to 2 amplitude is 0, just after transition amplitude is 2. Here we can see that amplitude value, and just after transition of amplitude value is 4 for t greater than t equal to 4. Similarly for t equal to 6 amplitude is 0 for just after transition. Now we'll get three function, one is the u of t minus 2, other one is the u of t minus 4 and third one is the u of t minus 6. I'll write one function will get u of t minus 2, second function will get u of t minus 4, the third function will get u of t minus 6. Now we'll compute the what will be the amplitude for the this each time. So amplitude will be 2 minus 0 for t equal to 2. So we will get 2 here. Amplitude at t equal to 4 will be 4 minus 2. So amplitude will be the subtraction of just before transition from the just after transition. So it will become 4 minus 2. So amplitude will be 2 here. Now for u of t minus 6, its amplitude will be 0 minus 4. So we'll get minus 4 here. Now we'll add all these three signals. So we will get 2 of u of t minus 2 plus 2 of u of t minus 4 minus 4 of u of t minus 6. So just you will have to check why what step signal is changing. Here signal is changing by amount of 2. So we are getting 2. Here signal is changing by amount of 2. Signal is increasing. So we will take plus 2. At t equal to 6, signal is decreasing by amount of 4. So we will get minus 4 here. So this is the criteria to select to represent the signal in terms of the step function. Now come to the another problem. Here, signal transition at t equal to minus 1, at t equal to 0, and t equal to 1. So we'll write u of t plus 1 and u of t and u of t minus 1. Three term will come here. We'll check the amplitude. Amplitude just before transition at t equal to minus 1 is 0. Amplitude just after transition is 1. So we'll get 1 minus 0 is u of t plus 1. Amplitude will be 1 u of t plus 1. Now here at t equal to 0, amplitude value is minus 1, and at t equal to 1, amplitude value is 0. So we'll get 1 minus 0 u of t plus 1. Then we will get minus 1, that means minus 2 u of t. Then we'll get plus u of t minus 1. Here you can see that one step is taken by plus 1 at t equal to minus 1. Here signal is decreasing by 2. Previously signal amplitude was 1. Now signal amplitude is minus 1 at t equal to 0. So signal is decreasing by amount of 2. So we will get minus 2 of ut, and at t equal to 1, signal is increasing by amount of 1 plus 1. So we can write plus u of t minus 1. Now come to the another problem. We'll have to represent this signal by step signal, by step function. So how we can represent it? But this signal is not looks like the step signal. It looks like some ramp and slope. But we can still represent this signal by step signal. So first we will have to consider this is the line. Consider this line is going till infinite. Consider like this. So we can represent this equation y by equal to mx plus c, and where m is the slope that we can compute by y2 minus y1 divided by x2 minus x1. So here, if we compute the slope, it will become 3 minus 0 divided by 4 minus 0. The slope value will be 3 divided by 4 for this problem. 3 divided by 4, and x is t here. So we can write 3 divided by 4t. If we write 3 divided by 4t, we write 3 divided by 4t, signal will go till infinite. But we will have to stop the signal at t equal to 4. But we will have to stop the signal at t equal to 4. For that, we need to use some window. If we use one step signal between 0 to 4, which says amplitude is 1, if we multiply it with the ramp signal, let us consider we have one step signal which is lie between 0 to 4, which amplitude is 1. Now if we multiply 3 divided by 4 t, that is going till the infinite, with a slope 3 divided by 4. If we multiply 3 divided by 4t with this step signal, so we'll get the signal in this window. Out of this window, this 3 by 4t is multiplying by 0. So we'll get 0 just after t greater than 4. So we'll get signal between 0 and 4. And at t equal to 4, our signal amplitude value will be 4. Just after that, signal value will be 3. Just after that, signal value will be 0. So what we are doing? This signal that we have already seen, we can represent it by u of t minus u of t minus 4. If we multiply it with 3 divided by 4t, we will get the signal function. So any signal can represent in terms of the step function if we multiply it with this window with amplitude ut, with amplitude 1. Now, signal sin t is defined between 0 to pi. Before that, before for t less than 0, signal value is 0. For t greater than pi, signal value is again 0. So here we will have to, if we plot this signal, we will get this kind of a signal. Sin t is defined between 0 and pi only. For t less than 0, signal is 0. For t greater than pi, signal is again 0. If we plot sin t and we multiply this with u of t between 0 and pi, so we will get sin t u of t minus u of t minus pi. So we are multiplying sin t with window u of t minus pi. That window lie between only 0 and pi. Now similar way, we have given one more function 0, value is 0 for t less than a, and value is for t minus a between a and b, and 0 for t greater than b. If we plot it, signal looks like this. For t equal to a, here signal value will be 1. So here t equal to a, signal value is 1. For t equal to b, signal value will be e to power b minus a. For t equal to b, signal value will be e to power b minus a. Now we will have to represent this signal in terms of a step function. Just we will write e of e to power t minus a. We multiply the signal with step, multiply the signal with a step window that lie between a and b. We don't multiply it. That means signal is going till infinite. So if we are multiplying e to power t minus a between a and b, we will get e to power t minus a u of t minus a minus u of t minus b. So this signal is limited, band limited. Its width is limited here in this case. Now there is another way to represent the signal. We have a given functions. We want to sketch the signal. How we can do here? Just look at here. The signal amplitude is 1 by 2, amplitude is 1 by 2, and function is given here u of t minus u of t minus 2. If we plot it, this u of t means signal is starting at t equal to 0, and amplitude is 1 by 2, and signal will end at t equal to 2. Amplitude is 1 by 2. So here point is that signal amplitude is 1 by 2 at t equal to 0, and signal amplitude is minus 1 by 2 at t equal to 2. So signal is decreasing by 1 by 2 at t equal to 2. Similarly, here we can plot this signal. If we plot this function, we have a given discontinuity at t equal to minus 1, at t equal to 0, at t equal to 1, at t equal to 2, and at t equal to 3. We have discontinuity at these points. Okay. Now we will have to plot the signal. At t equal to minus 1, signal amplitude is 1. So we will take one step by one, and this will go till the next discontinuity. Next discontinuity at t equal to 0, and this step is taken by 2. So we'll take two steps. So its amplitude is 1. Now amplitude is 3 here. Okay, and this amplitude value of 3 will go till the next discontinuity, and at t equal to 1 we have a discontinuity, and signal is reducing by minus 1. So we'll get signal like this, and amplitude will be 2 here. Now this value will go till the next discontinuity. Next discontinuity occur at t equal to 2 with amplitude minus 1. So signal will decrease by minus 1 here. We'll get this kind of a signal at t equal to 2. Now this signal will go till next discontinuity, that is at t equal to 3. We will get this kind of a signal at t equal to 3. So its amplitude is start from 1, 3, then this is the 2, then this is the 1, and this is the 0. So we can represent any function in terms of the signal or signal in terms of the function. Thank you for watching this video.